Hello everyone, welcome back to my channel. Today we are going to solve Leetcode problem number 104, which is maximum depth of a binary tree. So let's get started. So in this problem, we are given the root of a binary tree and we need to find the maximum depth, right? For example, if we're going to consider this example, if the longest path contains 3 nodes, right? Then the maximum depth is going to be 3. So let's understand the intuition before jumping into the code. So whenever I see a binary tree problem, I first think about whether the answer of a node can be calculated using answers from its children's node, like this. To know the depth of this node, we need two things, that is depth of the left subtree and depth of the right subtree, right? For example, in this tree we have depth of the left subtree, which is going to be 1, and depth of the right subtree, which is going to be 2, right? And once I know both the depth, the current node depth is very simple, which is going to be 1 plus maximum of left depth and right depth, right? I'm going to write over here, that is 1 plus maximum of left depth. I'm going to write over here left depth, comma right depth, right? So the extra one is added because we are counting the current node. This root node should also have to be added, right? And also we need to think about the smallest possible case. What is the depth of a null node? For example, if we're going to consider this node, we didn't have a left child, we didn't have a right child, right? So this becomes our base case, right? If there is no node, then we're going to simply return 0, right? So basically depth node is going to be 1 plus maximum of uh, left subtree comma right subtree, right? For example, in this case we have this 2, right? The right subtree is greater than the left subtree, so we have 2 plus 1, which is going to be 3, and that's what the maximum depth for this binary tree. So that's the entire logic of this problem. So let's see the code, and after that we're going to do the dry run of this code. So basically we are solving this problem using recursion. So for that we want to help a function. So I'm going to make a helper function like def. I'm going to name them max depth, right? And there I'm going to pass a parameter. And we're going to, first of all, we're going to write the edge case, which is when our node is going to be null, then we're going to simply return 0, right? So if node is none, right? Or we can also write like this: if node equals to none, both are same, then we're going to return 0, right? Then we have left height, which is going to be, we're going to call this function, which is going to be max depth, and here we're going to traverse the left side of this root node, right? So node dot left, right? Then we're going to traverse the right height, so I'm going to name them h, is equals to max depth of node dot right, right? And after that, we're going to return 1 plus max of left height, comma, right height. GHT height. Right. And also, we need to call this function. So I'm going to call this function, which is going to be max depth. There we're going to pass the root, and after that we're going to return the value. Return max depth. Okay, so we don't have to call this function. Simply we're going to write over here root. Now let's run this code. Accepted. Before submitting this code, let's see the dry run of this code. So basically we have this a simple binary tree. So we're going to pass the root node. So I'm going to pass over here 3. Then we're going to check whether this node is null or not. So this node is not null at all. Then we're going to call this function for the left height, right? And then we're going to pass node dot left. So what is the left node for this root node, which is going to be 9, right? So I'm going to pass over here 9. Then again we're going to check, no, this node is not null. Then again we're going to call this function, right? And this time we're going to pass what is the left node for this 9th node. We didn't have a left child, right? So basically we are passing the null value over here, right? And then we're going to check if this node is null. Yes, this node is null. Then we're going to return 0. Then this function is going to return back over here is 0. Then again we're going to check right node for this 9th, for this node, which is going to be null, right? We didn't have a right child, right? Then again we're going to pass the null value. Then again we're going to back return 0, right? Then we're going to check return 1 plus max of left height comma right height. So left height is 0, right height is 0, which is going to be 0 plus 1, right? Which is going to be 1. So basically we are going to return over here is 1, right? So left height of this binary tree is 1, right? So I'm going to undo this all, and now let's traverse the right subtree, right? So basically we're going to call this function again, and we're going to pass over here node dot right, which is this 20th node, right? So I'm going to pass over here 20, right? Then again this node is not null. Then we're going to call left height. Then again we're going to pass the node dot left, which is going to be 15, right? This node is not null. Then we're going to call this function again, and this time we didn't have a left child for this node. Basically we are going to pass the null value, right? So we're gonna return back a 0 value, right? So I'm going to return over here 0. Then again we didn't have a right child, which is basically we're going to get 0 again, right? So return 1 plus max of left height comma right height. So left height is 0, right height is 0 plus 1, which is equals to 1. So basically we're going to return back over here, and we're going to get 1. right? Now let's call for node dot right. So what is the right node, which is going to be 7? So this time we're going to pass over here 7, and again we didn't have a left child, we didn't have a right child, right? So which is going to be 1 plus max of 0 comma 0, which is again going to be 1. So basically we're going to return back over here is 1, right? And this time is going to be 1 plus max of left height comma right height. So left height is 1, right height is 1, which is going to be 1. 1 plus 1 is 2. So basically we're going to return back to this function, and this time we're gonna get 2, right? And here the right, here we're gonna get the 1, and here we have 2, right? Then we're going to return 1 plus max of left height comma right height. So left height is 1 and right height is 2, right? So which is going to be 2. So 2 plus 1 is 3. So our answer is going to be 3. And if we're going to check the depth of this rule, depth of this tree is going to be 3, right? So this is what the first height, then the second height, and we're going to get the third height, right? So this is what the maximum depth is, and here we're going to get our answer, right? Submitted, our code is submitted. So the time complexity is big of n, right? And that's it, the lead code problem 104, which is going to be maximum depth of binary tree. And if this explanation helped you to understand, so don't forget to like, share and subscribe. Thanks for watching, and I'm going to see you in the next video. Bye bye.